An interesting fact about the Cartesian plane is that it is made up of two number lines. The horizontal number line is known as the x-axis, while the vertical number line is called the y-axis. This is why any point on the plane has its corresponding value on the x and y axis. These values are called the coordinates of that point. Another implication of the Cartesian plane being number lines is that we can also represent the inequalities of two variables on the plane. So, if an equation is x is equal to 1, it means that irrespective of the value of y, x will always be 1. Hence, it is represented with a straight line. What if x is less than 1? We represent it with broken lines because the values of x do not include 1. But there's more. X is less than 1 means that x can be 0.6, x can also be minus 1, and so on. Hence, to get the region of possible values of x, we know from the line that this part contains numbers that are less than 1. Therefore, this is the region of possible values of x. What if x is greater than or equal to 1? Since x can be greater than 1 or equal to 1, we represent the inequality with an unbroken line. Furthermore, we shade the region of possible values of x. How about y is less than minus 2? We look at the y-axis as it is the number line for the variable y. We locate minus 2 and draw a broken line. Next, we check out for where we can get numbers that are less than minus 2, and they are found here. Hence, we shade. Now, let's combine two variables by representing x is greater than or equal to 2 and y is less than minus 1. We draw out the Cartesian coordinates, locate 2 on the x-axis, draw an unbroken line, and then shade the region of possible values of x with a pattern, of course. Next, we locate minus 1 on the y-axis, draw the dotted line, and finally shade the region of possible values of y with a different pattern. Interestingly, the portion that contains the two patterns is the region of the solution for both inequalities. Just as we can interpret the number lines for a single variable, we can also apply that to the Cartesian plane. For example, what are the inequalities if the shaded regions contain the possible values of x and y? From the x-axis, x is greater than or equal to minus 1, while from the y-axis, y is less than 3. We can go on and on with the two variable inequality on the Cartesian plane. But I will draw the curtain here. I'm sure you have learned something new, but I don't want you to stop here. Get questions and practice with them.